So this problem says evaluate. So we have 3 factorials that we're going to evaluate here. So think about what 82 factorial is. So this one here we're going to do first. Now if you try to plug that in your calculator, it won't work. It'll overflow. It can't do past, I think, about 70 something-ish factorial. So if you try to plug that in, it won't work. So what we do here is just think about what it is. It's 82 times 81 times 80, blah, 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 times 3 times 2 times 1. And then on the bottom, think about what you have down there. That's really 80 times 79 times 78, 3 times 2 times 1, because that's what factorials are. And if you can think about this idea here, what happens? Those all cancel, don't they? And then they cancel all the way down, actually. And the only thing I really have left here is 82 times 81 over 1. So that's really how this works right here. So this answer is really 82 times 81 because everything else canceled. And that turns out to be 6642. So there's our answer. So that's kind of a nice thing about this, is just kind of think about how those factorials work. Now for this number B here, it's a little bit different because there's more things I'm multiplying here, and I'm still dividing. So the first thing I look at is the biggest one. So I'm going to look at those two. So if I think of that same idea again, okay, that's really, I'm just going to leave that 4 factorial alone there. And then I have 9, and it's still times there, times 8, times 7, dot, 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 all the way down to 3 times 2 times 1. And then on the bottom, on the bottom I have 7 factorial. So that means 7 times 6 times 5 times 3 times 2 times 1. And what we see is everything cancels at this point. So think about what I have left there. I have 4 factorial, and then times a 9, and then times an 8. Now this one my calculator will do, but it's better just to kind of think of this by hand. It helps a lot with these. Factorial you got to punch in and stuff. It's just a little annoying. So anyways, so now 4 factorial is really 4 times 3 times 2 times 1. So that's 12. Times 2 is 24. Times 1 is 24. So my 4 factorial is 24. So I really have 24 times 9 times 8. And that's going to equal 1728. So there's my answer for the second one. Now let's move on to this third one. This is where understanding the factorials really comes in handy for these. And some people always ask, hey, why do I have to go so far? And you'll see what I mean by that. So when I look at this one here, n plus 2 factorial is really n plus 2 times n plus 1 times n. Now notice what I'm doing. I'm just going down 1 every time, right? So the next one's going to be n minus 1 times n minus 2. And then it keeps going all the way down to 3 times 2 times 1. Now somebody might ask, hey, why'd you stop at n minus 2? It doesn't really matter where I stop at. I just want you to get the idea of what the n plus 2 factorial is. And then when I draw my line, I get on the bottom n minus 1 times n minus 2. And I could keep doing n minus 3, n minus 4, but I'm just going to stop there because I really just want the gist of this. 3 times 2 times 1. And if I think about this canceling thing, that cancels with that, that cancels with that, and then I can go all the way down with this. So the only thing I'm going to have left here is n plus 2 times n plus 1 times n. So that's what my answer is going to be for that third one. So again, just using the idea of things canceling. And if you notice, I've done that for all three examples here. So there are my answers. So here's my answer for the third one then.